Imagine a magnet so powerful it could wipe every credit card on Earth from halfway to the moon. This isn't science fiction. This is a magnetar, one of the most extreme and fascinating objects in the entire universe. So, what exactly is a magnetar? It's a type of neutron star, which is the superdense core left behind after a massive star, much bigger than our Sun, explodes in a supernova. While a typical neutron star is already incredibly dense, packing the mass of our Sun into a sphere only about 20 kilometers across, a magnetar is something else entirely. A spoonful of neutron star material would weigh billions of tons. But a magnetar takes this density and adds an unimaginably powerful magnetic field to the mix. To put it in perspective, a common refrigerator magnet has a field strength of about 0.01 Tesla. A powerful laboratory-grade magnet might reach 10 or 20 Tesla. The magnetic field of our own planet, which guides our compasses, is a tiny fraction of a Tesla. The Sun's magnetic field is a bit stronger, but still relatively modest. A magnetar's magnetic field, however, can reach a staggering 100 trillion to a quadrillion Tesla. That's 1,000 trillion times stronger than a refrigerator magnet. This makes magnetars the most powerful magnetic objects known to exist in the cosmos. Their magnetic fields are so intense, they warp the very fabric of space-time around them. The creation of a magnetar is a violent and chaotic event. It's believed that a magnetar is born if the progenitor star is rotating incredibly fast just before it goes supernova. This rapid rotation, combined with the churning, convective motions within the collapsing core, creates a powerful dynamo effect. This dynamo amplifies the star's magnetic field to astronomical levels. It's a perfect storm of physics, where immense gravity, density, and rotational energy all conspire to forge this cosmic monstrosity. The result is a star where the magnetic energy is even greater than its immense rotational energy, a defining characteristic that sets it apart from other neutron stars, like pulsars. Life as a magnetar is anything but quiet. Their colossal magnetic fields are highly unstable. This instability leads to a phenomenon known as a starquake. Much like earthquakes are caused by the shifting of tectonic plates on Earth, starquakes are caused by the crust of the magnetar, cracking and shifting under immense magnetic stress. These starquakes are incredibly violent. They release vast amounts of energy in the form of high-energy X-rays and gamma rays, which we can detect here on Earth. These bursts of radiation are so powerful they can have a noticeable effect on our planet's atmosphere, even from thousands of light years away. One of the most famous events occurred on December 27, 2004. A giant flare erupted from a magnetar named SGR 1806-20, located about 50,000 light years away. In just a fraction of a second, the flare released more energy than our Sun produces in over 100,000 years. It was the brightest extraterrestrial event ever witnessed in our galaxy. The blast of gamma rays was so intense that it saturated detectors on multiple satellites and even partially ionized Earth's upper atmosphere, disrupting some radio communications. Imagine the sheer power needed to have a tangible effect on our planet from a distance of 50,000 light years. It's a testament to the extreme nature of these objects. These outbursts are not just random explosions. Scientific research suggests they are directly linked to the twisting and reorganizing of the magnetar's internal and external magnetic field lines. As the field lines snap and reconfigure, they release stored magnetic energy in a cataclysmic burst. It's a process called magnetic reconnection, but on a scale that's almost beyond comprehension. Besides these giant flares, magnetars also emit more frequent, smaller bursts of X-rays. Astronomers who study these objects are like cosmic seismologists, analyzing the patterns of these bursts to understand what's happening deep inside. The number of magnetars we know of is relatively small. Only a few dozen have been confirmed within the Milky Way. This is likely because their active, high-energy phase is believed to be quite short in cosmic terms. A magnetar's intense magnetic field is not permanent. It gradually decays over a period of about 10,000 years. As the field weakens, the starquakes and a magnetar's brilliant outbursts become less frequent and less powerful. Eventually, it settles down to become a more ordinary, quiet neutron star. So the spectacular light shows we see are from a relatively brief, youthful phase in the life of these special neutron stars. One of the most exciting recent discoveries in astrophysics is the connection between magnetars and a mysterious phenomenon known as fast radio bursts, or FRBs. FRBs are incredibly brief, yet extremely powerful pulses of radio waves that flash from distant points in the cosmos. For years, their origin was a complete puzzle. They last for only a few milliseconds, but in that tiny sliver of time, they can release as much energy as the sun does in an entire day. In 2020, astronomers hit a breakthrough. They detected a fast radio burst coming from a known magnetar within our own Milky Way galaxy, SGR 1935 plus 2154. This was the first time an FRB was ever traced back to a specific object, and it provided a smoking gun that strongly links at least some FRBs to magnetars. The theory is that a starquake or a major reconfiguration of the magnetar's magnetosphere can generate these intense, focused beams of radio waves. This discovery has opened up a whole new window for studying magnetars and the extreme physics that govern them. By studying FRBs, we can learn more about the engines that power them. The environment around a magnetar is a truly hostile place. The magnetic field is so strong that it would distort the electron clouds of atoms, stretching them into long, thin needles. Chemistry as we know, it would be impossible. The very laws of quantum physics behave differently under such extreme magnetic influence. Even the vacuum of space around a magnetar is not empty. The intense field can spontaneously create pairs of particles and antiparticles, a quantum effect known as the Schwinger effect. The space around a magnetar is a seething foam of virtual particles, warped by gravity and magnetism. It's a natural laboratory for testing the limits of our understanding of physics. If you were to approach a magnetar, the dangers would be numerous. Long before you reach the star itself, the magnetic field's tidal forces would tear you apart, atom by atom. The intense radiation would be instantly lethal. It's a place that humans can only ever hope to study from a very, very safe distance. Despite their destructive power, magnetars are crucial for understanding the universe. They push the boundaries of physics and challenge our theories of matter, gravity, and magnetism. They represent the most extreme state of matter we know of, and by studying them, we learn more about the life cycle of stars and the fundamental forces that shape the cosmos. Every burst of gamma rays, every fast radio burst, is a clue sent across the vastness of space, a message from one of the universe's ultimate magnets. Scientists use a fleet of space telescopes, like NASA's Chandra X-ray Observatory and the Swift Gamma Ray Burst mission, to keep an eye on these cosmic beasts. By analyzing the light and energy from these objects, they can piece together the story of their violent lives and the physics that makes them tick. The study of magnetars is a field full of unknowns and excitement. We are still just scratching the surface of understanding these incredible cosmic objects. From their chaotic birth in the heart of a supernova to their eventual, quiet fading, magnetars are a powerful reminder of how dynamic and extreme the universe can be. They are the ultimate magnets, cosmic powerhouses that light up the galaxy with their fury, and they hold the keys to some of the deepest mysteries of physics. I hope this has given you a glimpse into the wild world of magnetars. The universe is filled with wonders, and these are certainly among the most magnificent. Thanks for watching. For more amazing journeys into the cosmos, be sure to subscribe to Space Repo